Now the dot product of a vector. This is very important. Dot product and cross product. We have been waiting for that and now it's here. Dot product, it is also known as a scalar product. Dot product is also known as a scalar product. So what is mentioned in the definition? The dot product is magnitude of one vector times the magnitude of the projection of the second vector onto the first vector. So definition, don't worry about definition. Let us understand here by taking example. Say for example, there are vectors P and Q are mentioned here. Vector P and Q. And what is dot product? Dot product, it is a projection. If I take a perpendicular line from vector P, this is, so I can find projection of vector Q, that become Q cos theta. We know trigonometry, we know trigonometry, right? So here it is just a product of Q cos theta multiplied by P. Or you can take opposite side, take projection of P on Q, projection of P on Q, so it gives us P cos theta. So it is a multiplication of P cos theta multiplied by Q. P cos theta multiplied by Q. In both the cases, we are not taking direction. Here only magnitudes are taken. Therefore, final result becomes mode of P, mode of Q multiplied by cos theta, and therefore result of dot product is always a scalar product. Result of dot product is a scalar product, and it is not having any direction. See, no direction. It is not towards P, it is not towards Q. It is just the multiplication of, it's a vector times magnitude of opposite projection. It is just a projection of two sides. So here P dot Q is equal to PQ cos theta, and that become a scalar product. Now in sometime exam, you may have some questions that component of B, or let's just move here A and B. So what it mentioned, component of B along A bar. So you just need to take projection. Component of B, that means its projection. That is what? That is B cos theta. That is B cos theta. Right. So we know that A dot B is equal to A mod B cos theta. Right. If you just take cos theta, B cos theta in a single side, so B cos theta mod B is equal to A B vector divided by its mod A. Similar here, this is A B vector divided by its mod A, and we know that A vector divided by its mode, so it gives us unit vector. Right. So ultimately, projection of B, it's a projection in a unit vector A, Similar for the component A along B bar, you can prove that part. Right. Ultimately, we need this one. So this is component of B bar along A and A bar along B bar that you have to work out. Now next is properties of dot product of two vector. Here it is very important. You can find several questions based on this. First is the property of commutative property. That means order of matrix does not matter. It is mentioned here. A dot B is equal to B dot A. A dot B is equal to B dot A. The values are not going to change. Whatever values are here, left hand side if I change the order, it is not affecting the final result, because A dot B is equal to AB cos theta and B dot A is also AB cos theta. So it is not changing its value, and that property is known as commutative property. Remember, you may have some questions based on this. So dot product is having a commutative property. That means order of matrix does not matter. You can have any order. Result is similar. There is no change in the result. Second property, it is a distributive property. Distributive property. From the word also understand there is some distribution part. So numbers, or you can say vector, can be distributed to all other. Example is given here, A dot B plus C. So that A can be distributed like A dot B with the first component as well as with the second component. So A dot B plus A dot C is possible. So that become a distributive property. Say for example, here it is A dot in bracket B plus C plus D. So you can write A dot B plus B dot C plus C dot D. Is it okay? Is it okay? No. It should be A dot B plus A dot C plus A dot D. This is correct. Right. So this is a distributive property. The number can be distributed to all, like algebraic. Then next is a binary property. A binary property. A vector can be assigned to each of the pair of the element. Say for example here, it is A dot R. If it is not, R is not a board, so that means it is a scalar. So you can have R, you can take outside, that is okay, and it gives A dot B. The distributive property will work here, A dot C. And scalar you can take outside, or scalar if it is inside, then also there isn't any issue. So you can move scalar in the case of a bilinear property. It is a bilinear property. So I think mispronounced. That is known as bilinear property. Next is scalar multiplication. If there is a scalar, x small x is a scalar value, small y is a scalar value. So you can directly multiply x multiply by y, and you can have A dot B. So scalars you can have similar to algebraic property. There isn't any difference in the property of dot product, or simply you can say algebraic property. See, ultimately dot product is a scalar property, so all the algebraic properties are here applicable. And then next is parallel. If two vectors, say for example A and B, both are having a parallel vectors, this is A, this is B. Two possibilities are there. Either it can have, here it is 0 angle, and here it is 180 degree angle. Theta is 0, theta is 180. So we know that equation A dot B is equal to mod A mod B cos theta. So when cos theta is equal to 0, cos theta is equal to 0, that means the value is 1. And in this case, AB, it gives maximum value. So when two vectors are parallel, in the opposite direction also, it always gives us maximum value. It gives us maximum value, right? So A dot B maximum value is equal to always mod A mod B. Both the magnitudes are multiplied, right? Because projections are, the 100% projection is visible on the opposite side. The next is orthogonal. Yeah, this might be a new word for you. Orthogonal, that means a perpendicular. Simple meaning is that orthogonality, that means a perpendicularity. Suppose a vector A, this is vector number A, and this is vector number B. Now in this case, what is angle? Angle become 90 degree. angle become 90 degree, and therefore the projection of B, if we consider, then the projection of B is 0. Therefore A dot B, that is 0. Or ultimately you can see cos theta, that become cos 90, and 90 cos 90 is equal to 0. Right. So this orthogonal property is more important. You may have few questions on that, and we know A dot B is equal to 0. A dot B is equal to 0. So that we need to understand. In a detail. Now next is the scalar product or dot product. Suppose A vector, it is having A1 magnitude and I presenting it's a unit vector along x direction. A2 its magnitude and J representing a y direction. And another B, it is there B1I plus B2J. It is a similar case here. How to do a dot product of a scalar? Right. This is our question. So there is a method in the mathematics called FOIL, FOIL method. It represents F is for first, O is for outer, I is for inner, and L is for last. Let's solve it. So A dot B, let us consider the first component, that is the multiplication of first to first. So that gives us A1, B1, I multiplied by I. Right, I multiplied by I. Then outer, So outermost, this is outer and that is outer. So what it gives? A1, outer is B2, I, J. A1, B2, I multiplied by J. Right. Just to avoid cross, we just put here dot. Fine. Then third, it is inner. Let's have another color. This is for the inner. Means two inner portion. So this become inner and this become inner. So A2 B1 J I. A2 B1 J I. And the last. This is a last. A2 B2 J J. I think you understood this very well. Now, when we talk about I dot I, that means what? This is I along x-axis, another I along x-axis. So therefore, theta is equal to 0. And we know that cos theta, when it is 0, it become 1. That means I cross I, I multiply I, it become 1. So for the parallel, it become 1. And when I dot j, when we consider I multiply by j, so this is I and that is j, and theta become 90 degree for the Cartesian. And we know that cos 90 is equal to 0. Cos 90 is equal to 0. So what happened? Here I dot I, that become 1. Similar j dot j become 1. But what about ij? Ij, that is 0. Ji, that is also 0. So finally we just need to have A1, I become 1, JJ become 1, and that is A1, B1, A2, B2. And during calculation of dot product, you may skip this rate and you can directly write this. So in the case of dot product, the multiplication of A, right? A, B1, and then this one, A2, B2. Only it's single component with I multiplied by I, J multiplied by J. It is just required. So remember that part. Let's solve example. Find the dot product of A is equal to 1, 2, 3 and B is equal to 4, minus 5, 6. And what kind of angle the vector would form. Let's see. So formula of the dot product, and we know that A is equal to 1, 2, 3, B is equal to 4, 5, minus 5 and 6. And dot product it is equal to, that is A1, B1 plus A2, B2 plus A3, B3, that is dot product. A is equal to 1, B is equal to 4, A1, 1. So multiply this to, another is multiplication of 2 minus 5. And this one is 3 multiplied by 6. So we can have solution. It is 12. A dot B is equal to 12. A dot B is equal to 12. And you comment me what kind of angle the vector would form. Comment me in the text. Example number 14. Two vectors A and B are given. So A, see, you can write vectors in the form of this bracket, or you can write 2i minus 3j plus 7k, like that. Find the dot product. We know that the method is like that. Here the similar equation is to be followed. 2 multiplied by minus 4, right? Then 3 multiplied by minus 3 multiplied by 2, that is the solution. And here 4 multiplied by minus 4. So ultimately it gives us minus 42. Solution is minus 42. Vector dot product gives a scalar. Dot product gives a scalar. Right? Let's have example number 15. What is mentioned? If the vector P is equal to A, 3, Q is equal to A minus 2 minus K, perpendicular to each other, find the value of A. So see, when there are perpendicular, so we know the dot product of vector that becomes 0. Dot product of the vector that becomes 0. So that means vector dot another vector is equal to 0, and we know that multiplication is A square. This is minus, right, multiply by this J. Ultimately you will get the solution is equal to that, and you can find solution. A is equal to minus 1 comma 3, B is equal to, like that. Similar solution you will have with you. And example number 16, you try both the examples by yourself. I am just showing here. Find the component of 3i. We know what is component. This is vector A, vector B, and the component of vector theta B on A, that is B cos theta, and opposite is, for opposite it is become A cos theta, right? So similar, we already seen this equation. A bar B bar divided by its a B mode, and you just need to find out its a mode. Mode means 3 square plus 4 square, right? So you get answer like that, and that is your answer. You solve both the examples, are very simple, and you can get your answer with this. Now example number 17, find angle between this two, find angle between these two. So here we also have another equation, cos theta is equal to A dot B dot divided by AB. Put the values here and you will have your solution. You also try this example by yourself, not spending much of time on that. That become your homework problem. And this question number 6, determine the dot product and the angle between the vectors. Two vectors are given. So this is your homework problem. This become your homework problem. So pause the videos and what I suggest that you solve this 4 examples. You should solve this 4 examples now. One more, question number 7. F1 is equal to 5i plus 4j plus 3k and F2 is equal to 4i minus 2j minus 4k. Show that F1 and F2 are at right angle to each other, and you can use the orthogonality property. What was orthogonality property? You just go back to certain slide, so you will understand. A dot B dot is equal to some value, it was there, 0 or not. Solve it. You can do it by yourself. And one more question we have. Determine the projection of force. We just need to have projection of force. Projection we already understand. This is A vector, this is B vector, so that is known as projection. B cos theta, that is the projection. That is the projection. Solve this example and put your answers on the comment section. So let's say a very important question. If you see our initial stage, we have seen some scalar and vectors, and this part was skipped over there. So one question is that why work done is a scalar product. First, what is a scalar product? And a dot product of any matrix, what it gives? A dot product is a magnitude of one vector. See the word you understand here, magnitude. Magnitude of one vector times the magnitude of projection. That means it is a multiplication of magnitude. And it is a multiplication of P and the projection of opposite one, like Q cos theta. Therefore, ultimately, if there is a multiplication of magnitude, if it is just a multiplication of magnitude, that means it gives a scalar. Right? So, dot product of vector quantity is always a scalar, which means it has only magnitude and no direction. And therefore, work is equal to force multiplied by its displacement. It is a dot product, and therefore it has no direction, it has only magnitude, and therefore it become a scalar product. If we apply force in the direction, so it displacement, right? If it is in the same direction, so we can get 100% force multiplied by displacement. If it is in other direction, so we can have a third direction, but ultimately it does not give any direction for that, right? And so we use here magnitude of force and magnitude of displacement. Ultimately, therefore, work is not a vector, but it is just a scalar product. Let's have another example number 19. The object goes through displacement. The displacement vector is given. D is equal to 3i plus 1j meter, and the force is given 4i plus 2j Newton. So we know that force, what is the work done by the object? So we know that W work is equal to force multiplied by displacement. And the force vector, it has to be a dot product to get a final solution. So 4 multiplied by 3. We know that this method we already studied, right? The FOIL method we already studied. The first, that means the first is to be multiplied. This is the first is to be multiplied. First. Then next is outer. So this is outer multiplied by outer. That gives this solution. Then inner. So inner multiplied by inner. So here it is inner. And the last. This is last. So this is last. So it becomes. We know this method. We had this method previously also. And we know that I multiplied by I, that means axis, if it is axis in the similar direction, theta becomes 0 and cos 0 is equal to 1. Right. So only I of I that become 1, but if it is I of j, I multiply by j, I dot j, so theta become 90 degree and cos 90 become 0. So it has to be cancelled out. It has to be cancelled out. So ultimately, you just need to multiply with this I and 2 with 1. This green portion you may skip. This is only for our understanding. This is here is only for our understanding. So work done is a scalar quantity because it does take magnitude of both the vectors. Example number 20, find the unit vector in the direction of vector A 3i plus j minus 5k. We just brought one example for a change in any direction. So we know that unit vector A is equal to vector A divided by its magnitude. Magnitude is equal to, it's a 3 square plus 1 square plus 5 square. You can get this answer and it becomes 35. So ultimately 3 divided by 35 root 1 by 35 root, and that gives us our solution. Very simple one. Very simple one. And this question number 6, do it yourself. Why this quantity is a scalar quantity? One is power, which is having force, and the multiplication of velocity, to vector quantity, then current, J, current density multiplied by its area, and magnetic flux. Prove this and answer me in the comment section.